My name is Dr. Harvey Miller, and this is the third and final segment on our chapter on inventory management. This is a course, this is part of a course on operations management offered to our business students in the Sobe School of Business at St. Mary's University. So, in the first segment, we focused on how much to order, the economic order quantity. In the second installment, we focused on the production order quantity model, where there is simultaneous production and usage. And then we also focused on the question of when to place an order, which has to do with reorder points. We mentioned that reorder points essentially is the inventory level that you have when you place an order. If everything is deterministic and constant, it is very simple. So you just calculate the expected demand during the lead time, or I should say the demand that the expected demand during the lead time, and that's your reorder point. But now, when we have uncertainty, we must now carry safety stock to assure some level of service. And so once we determine what our service level will be for the period during the lead time, we could then add some safety stock, which we have to carry, that allows us to hedge against changes in the demand or the lead time during that period. Okay. So now we want to focus on another inventory model, which has to do with a bit of uncertainty as well. It's called a single period inventory model. So this particular inventory model was identified, or at least popularized, as a what we call a news vendor model. Another way to think about it is a single period inventory model, where the goods is only has value during a single period. It's like a perishable item. So the reason why it is popular in the news business is because of the idea that if you have a daily newspaper, no one wants to read yesterday's news. I shouldn't say no one wants to read it, but people are buying today's paper. And tomorrow they'll be buying tomorrow's paper, not today's paper. So the idea is that if you are a news vendor and you're trying to determine how many newspapers you stock, you have to balance the risk of stock out with the risk of having excess inventory or in excess newspapers, because you're going to have to get rid of those excess newspapers. Nobody wants them unless your picture is in that newspaper. You're not going to go looking for the one the day before if you didn't get it on that day. So the idea is that the item that you're selling has a single period where it is of value. We could use that for bakeries that sell fresh bread, and at the end of the day, they want to find a way to dispose of that by usually reducing the price, and then afterwards, perhaps you could take the excess inventory that was not sold, even at the reduced price, and maybe sell it to a farmer, something like that. So this particular model, the inventory item, is a single lasts for a single period. So only one order is placed for a product. Units have little or no value at the end of that sales period. And so we want to model this problem. First thing is that, remember, at the end of the period, if you have an item that is left, it has very little salvage value. It could be worth nothing or has very little salvage value. Or um, if you run out, then you lose the value of that profit that you could have made. And so you're trying to balance those. So we have two cost items that we consider. One is the cost of a shortage, which basically would be the cost. You could set it to the value of the profit that you've lost. So it's like an opportunity cost. You've lost that. And then the cost of overage, which has to do with, um, you know, not selling this item. So therefore, if you incur the production costs, then that's what it costs you to have that item at the end. But then in some cases we may have salvage value. So you could reduce your costs. You say if it costs me uh, $2 to make an item, and at the end of the period, I don't sell it for my selling price of 350, but I could actually offer it to somebody for $1. Then I have $1 salvage value. It cost me $2 to make it. So my real cost of having excess inventory is $1 per unit. Okay. So we will denote those items by as follows. CS will be the cost of being short per unit, and CO being the cost of being over. Now, to get the model, we need to consider the following. We want to have a service level that we will call SL, which is the probability that we will be able to meet the demand. So we want to stock a quantity that gives us a certain service level. So that means that the probability of the demand being less than or equal to that quantity that we want to stock, right, would be our service level. So if that's 90%, if we want 90% of the demand to be less than an amount, our service level is 90%, and so on. If it is 95%, and so be it. So we're going to work with this concept called the service level. So here's how we do. We want to balance the expected cost of a shortage with the expected cost of being having excess. So SL is our service level, right? Remember that. So if we when do we have so our service level SL multiplied by the cost of being over, because remember the only time you'll be over is if the demand is less than the amount that you store, and that was all part of your service level. So the chances of you having less than the amount that you stocked is SL. So that's where you would have the overage, right? Or you'd have excess. So the service level times CO, right, should be approximately equal to 1 minus the service level. Well, what is the 1 minus the service level? That's the stock out risk. Okay, the risk of a stock out times the cost of stocking out, CS. So that's what we're trying to balance. The cost of having excess, the expected cost of excess, which is SL, the service level, times CO. So let's make a note here. SL is the service level, which essentially is the probability that the demand will be less than or equal to the quantity Q that we stock. And that's how we define it. So when the demand is less than the quantity that we stock, we incur excess or overage. And so the expected overage cost, which is this, must be equal to the expected shortage cost. If we rearrange this formula, we will get SL into CO plus CS. In case you're not sure, you could do the mathematics. Is equal to CS. Okay, so I'm multiplying CS by 1, I'm multiplying CS by SL, and then I'm moving the SL. I'm collecting all of the SL, the variables that have SL in them. So you will have SLCS and SLCO. Well, the negative from here will turn into a positive when I bring it to the other side, and all of that good stuff. So you should know how to do that by now. So that gives us CS. Now if I rearrange this formula and express SL, so I will have SL is equal to CS over CO plus CS. And that's the formula that you see here. Right? That's this formula right here. So essentially, we want to stock an amount that will give us a service level equivalent to SL. And so what we do is we say, all right, if we have our demand being a normal distribution, all right, then we want an amount Q that will give us, this is our service level, SL, and this is shortage, 1 minus SL, right here. That's what we're looking for. So if we know the average demand, D bar, then in that case, we know that there's a Z associated with the Q star right here. And so what is Z? This Z will be equal to Q star minus D bar over the standard deviation of the demand. And if we rearrange everything, we'll find that Q star is equal to our average demand plus, so this little piece right here, which will be Z times the standard deviation of the demand. Okay, that's essentially it. That's how we find our optimum quantity. Oops. From the average plus the extra that we have to keep just in case of uncertainty. All right, let's take a look at an example. We have the average demand mu, 120 per day. We have the standard deviation, 15 per day. And so, excuse me, cost of a shortage is 125 minus 70. So essentially, we're going to have a salvage value of 70 cents. It's going to cost us $1.25 to produce it. And then overage. Sorry, the selling price is $1.25, and then it costs us 70 cents to produce. So if we're short, we miss out 55 cents profit. It costs us 70 cents to produce, but we could salvage it for 30 cents, which costs us 40 cents in terms of overage costs. So computing this value, we have here CS over CS plus CO will give us a 57.9%, and so slightly more than the average. And so here we go. This is the service level, 57.9%, which corresponds to a particular Z value. Let's see what Z value corresponds to. The Z value it corresponds to is 0.199. Okay, we could use Excel to help us with that. Norm's inverse, and you put the cumulative probability, and we'll give that to you. So if you go back to the formula that I mentioned over here, where the quantity is Q, is the average demand, plus Z times the standard deviation of demand. So our average demand was 120, right? So our optimum stocking level Q was 120, that's our average demand, plus our Z value, 199.199, times the standard deviation of the demand, which is 15. And that gives us the 123 papers. All right. So it's just an application of that formula that I mentioned to you above. Cool. So this whole idea is balancing the risk of a stockout with the risk of actually having excess. Let's close out on the fixed period system. Well, what do we mean by fixed period versus continuous monitoring? So I mentioned to you in the last video that the continuous review system is one where we monitor the inventory all the time, and then when we hit the reorder point, we place the order. We would have to do that if we want to have a reorder point system. Okay, so your inventory is this is Q. You have to monitor it when you get to your reorder point. Okay, this is your lead time. So that's your ROP, your reorder point. When you get here, you place the order, and then you receive the order. So how do you know when you get to that reorder point? That's when you have to do the continuous or perpetual review. Point of sale systems allow us to do that relatively easily, so that's great. And then so once we hit the reorder point, place the order for queue comes, and then if your demand is certain, lead time is certain, then we know exactly what to expect. In a periodic review system, things are a little different. It's kind of like there's some risk associated with it for sure, but it is one where you don't want to spend too much effort monitoring your inventory level. So just imagine, um, let's contrast the two methods this way. Think of your car, if you have a car, and you decide that when I have a quarter tank, when I get to a quarter tank, I will fill up. So what happens now is that you get to a quarter tank, you fill up. Quarter tank, you fill up. So that's the reorder point system. You go to continually monitor your gas level until you hit a quarter tank. With the periodic review system, you might decide, I'm going to check my gas every weekend and then see how much I need. So you might very well find in the first time you check your gas, you didn't really use that much. And so your targeted inventory level is a full tank. What happens now is that if you were three-quarter tank left when you check the inventory, your gas level on the weekend, you just put in a quarter tank. Then the next weekend you check again, you're down to a half tank. Then your other quantity is going to be a half tank. Then the next time you check again, maybe it's down to a quarter tank. So your next inventory order is going to be three-quarter tank. Now, if let's assume that you're not paying attention to your gas gauge at all, in other words, what if you had no gas gauge? And it is possible that you could run out of gas before the weekend comes. So there's a risk of a stock up. It might just very well be that you were driving some very long distances. Maybe you're a salesperson. The first couple of weeks you're working mostly in the city in Halifax, and then all of a sudden you had to do some long trips outside of the city. In which case, you would have consumed more gas than usual, and then you could actually run out. Well, that's the difference between the periodic system and the continuous review system. So inventory counted only at the end of the period. Or order brings inventory up to the targeted level, so the full tank of gas as we were talking. Only relevant costs are ordering and holding costs. Lead times are known and constant, and items are independent of each other. So that's a typical kind of periodic review system. Okay, and this diagram just sort of shows you what I was talking about with respect to the car. So P is our fixed review system. You can see our inventory level is here, and so therefore we only need to place an order Q2. The next time we check again is down here. We have to place an order Q3. But if you notice, Q3 is very different from Q2. It's much bigger, as a matter of fact, right? And then you check again after the end of the period. You see Q4 is a lot less. So that's the way which you deal with this. And there are models for calculating the cost of that system, but we are going to ignore that for now. All right. So fixed period system, the inventory is counted at the end of each period. Maybe scheduled at convenient times, like on a Saturday, for example. Every Saturday we're going to check the inventory level. Um, Appropriate in routine situations. Um, so if the situations, as you say, don't vary that much, then we could actually stick to that system. And may result in stockouts between periods, as I just mentioned to you with the example of the car. If your usage rate change, then in a case like that, you could end up running out of gas, right? But of course, we always look at our gas gauge, so we would not be using a periodic review system when it comes to gas. Nobody wants to run out of gas, and it may require increased safety stock as a result of that. Okay. So this brings us to the end of our chapter on inventory management, and it is extremely important for organizations that are either manufacturing or retailing, or even those that are providing services, where you have to manage the inventory level, right, of the facilitating goods, the goods that you need to provide the service. So, for example, if you are repairing automobiles, you want to look at the inventory level of things like oil, fluids, and other things like that, small like parts like light bulbs, etc. So things that are universal to cars, screws, bolts, you would have inventories of those, and you'll have to manage that. Okay, so that's the situation. In not-for-profit situations, it's no different. If you're running a facility that's providing care and you need products to provide healthcare, and you need products, whether it's sanitary products or name it, whatever the facilitating goods are, whether or not it is hand sanitizers, tissue paper, things of that nature, you're going to have to deal with that. Okay. And then, of course, in disaster situations, managing inventory levels to be able to provide services to the people in need, it becomes even critical. And then you have to do those with very short lead times. So, inventory management is important in multiple situations. And if we don't get it right, it can be a very costly situation for companies. But you're trying to balance the cost of managing inventory along with the quality of service that you're providing. That's the whole reason why we manage inventory, is to balance between the cost and service. Okay, so see you in the next video.